Hello, welcome to Learning OCaml. So I'm kind of just recording myself recording myself learning OCaml from scratch, following a book, following really, there's such a, the OCaml website has really, it's a great website. And they have lots of books and there are so many courses, okay, there are at least 3 or 4 full-time, full semester courses on YouTube that you can watch. This is me trying to set up NeoVim. So I'm kind of watching this OCaml Programming Correct, Efficient, Beautiful from Michael Ryan Clarkson. He's teaching OCaml Programming at Cornell. I think it's Cornell. Is it Cornell? It's Cornell. I think it's Cornell. And it's, I don't know, it's really nice. And yeah, I'm really enjoying it. And yeah, installing. So I've used in this book, you get the instructions how to install OCaml. And in the last video, which is kind of funny, I've used, let's see if it will turn up OCaml. I've used this. You see this? I was kind of playing with this, right? Like 12 and 12 plus 12. And then I said like, how come I cannot even go back and forth, and the interface is really so bare bones. I had no idea that there is actually, when you install OPAM, why is OCaml this? Maybe UTOP is built on OCaml, this thing. Anyway, the UTOP is the interpreter. So let's exit this with 0, this, and let's start UTOP. So UTOP is it looks really nice. It looks like you can actually drive the thing. UTOP, and look at this. Welcome to UTOP. This looks so nice, and it has all these nice lights and blinking things and arg array. I don't know what's this. I don't know, are these some types or something? But anyway, it looks really nice. It looks like when you see this, you feel like, okay, I want to try it out, you know. And it looks much more friendlier than, let's say, Python interpreter or GHCI. Yeah. So I'm just gonna spend some time, and because it's okay, although last time I was reading the book and I came to the end of here. I think I came here to the end, write a function, write a recursive function. Is GCD here, or did he do GCD? I was trying to understand the GCD. And in the meantime, I was also looking and chatting with ChatGPT to explain me the GCD in a couple of ways how you can, you know, and then I was trying to make like this, look at this. So I would, you know, draw the GCD and just do it by hand. It helps to do it by hand, actually. And the most simple algorithm that I did understand from GCD is the one that is the most inefficient. The one where you compare the two numbers, A and B, and you see like, so you do like let GCD AB. Wait, maybe I should show it. So it just compares the two numbers. Like it takes the lowest number of the two numbers. So let's say 12 and 18, it takes the 12, and then it compares like A mod, so A mod guess it will be 12. So 12 mod 12 is 0, true, but B is 18, so 18 mod 12 is 0, well, no. There's this sign. You see, I have to go through it again. But you just somehow step down. The recursive call does the guess -1, and then you do the same thing with 11, 10, and so forth, until you get to 6 that actually can divide both numbers without the remainder, which actually comes then to an end. Now, what would be interesting for me is to write both, and I cannot do it now. So I'd like to do an imperative style of GCD and the functional style of GCD and really run through it and maybe to try some other examples. So I've checked with ChatGPT. Is this open? Oh, I've closed it. complete setup. ChatGPT. So I was, let's see, how's my video encoder? Maybe a bit better. Maybe it's better because I did increase the buffer size. Yeah, I had a problem with OBS. My CPU was really too high. And I'm not sure if, okay. So, yeah, I don't need this. Yeah, since abstraction in programming, right. CPU is jumping, yeah, linear descent. And then I was also, you know, it would be nice to make, to check out these smaller kind of quick sort would be also nice to try it out. Monte Carlo, these are a bit more complicated. I was curious about simple, I guess, algorithms such as the Euclid ones for GCD, and to implement them in OCaml and to like just try, because I feel like it needs a lot of practice. You can understand how, I can understand how a recursive call works, and it's almost like my mind, it's really slow. So I'm looking at the evaluation, okay, I get it, but the next day I get it less. So I've noticed, you know, mentally there's this kind of an ongoing wave goes up, wave goes down thing, and especially because I feel I have to write a lot of them, and then that it sticks, you know, that it sticks. Matrix based C, yeah. And then I was asking ChatGPT to really explain it to me because, yeah, this one. Yeah, okay. So I'll just start John Whittington. So we kind of did here, I should repeat this, right? I should repeat this. So, okay, first we did numbers, right? Which is kind of simple, which is a value actually. Yeah, you could say we start with numbers, but then you should say what? We start with letters, right? This is a char. I wonder if a string, is this a string with like double quotes? String. Yes, string is with double quotes. Will it work if we do it like this? No, it will not. It will complain. So, okay, we have a number, 1. So let's do a char, O, this. And let's do a string, 1. So, okay, we have an int, and it says an int, a char, and a string. And yeah, we don't have to actually annotate, but we could annotate our types. But as I learn OCaml in first types, you know, so it's not like, I don't think you have to. Okay, now I'm going too far. So let's check here again what he did, and I just have to practice it. So again, this is just me recording myself trying to learn OCaml. So yeah, it's fun. OCaml 200. Yeah, so let's say we have a value. I said 2 times 2 times 2, 2 times 2 times 2. And we have another value. But then he says we could give it a name. Let X. So now he starts with a name. So also in this course, they call this let definitions. I think it's called let definition. He's making a subtle distinction between an expression and a definition.
We've been working so far with expressions as the fundamental building blocks of OCaml programs. Now let's look at a second kind of building block, which is a definition. A definition lets us give a name to a value.
Okay.
This is essentially the notion of a variable from other programming languages, except that the variable's value can't change. So for example, we could say let x equal 42. We get a response back from utop, and now x means 42. So let's take a close look at...
Well, that's funny. I read this there is one more nice book and also courses. I think it's called Abstraction OCaml, what do you call abstraction? OCaml. And it's nice how he said, because sometimes when they teach, they say, like, in this language, the variables are immutable, you know, like in OCaml and Haskell. And in that book, he's saying, like, it's nice because it's a more like step back kind of a thing to say. It's a certain type. So, like, it's like you have, it's like you say you have two types of variables. You have a mutable one and immutable one. So he was saying that a mutable type of a variable will change, and immutable type, how did we say, programming abstraction, I think programming abstraction, programming well abstraction, design and computation. Is this Harvard notes? Yeah, it's this. This is a PDF. So naming and scope, values and types. Like, check this out. This is really nice. Can I toggle sidebar? Let's do page fit. Is it page fit? No, page widths. So OCaml is value-based, strongly, statically, implicitly typed, functional. This is a nice book. It's kind of very mathematical, but you know. Floating point, exercise. Use the OCaml REPL to calculate the value of the golden ratio, proportion thought to be especially pleasing to the eye. You'll want to use the built-in square root function for floating point numbers. Be careful to use. Oh, this is nice. Now he says here how to combine strings with the caret sign. So that's like, yeah, that's like hello, right? And then you do a caret sign, I think it's called. This sign and then world. So this will make a string hello world. But maybe I've skipped this part. I'll try to find it like this. I think of type variable. Let's try like this. For each of several values of the variable, of this type of a variable. Yes, this is nice. Look at this. So what he's saying here is this mechanism, right? The state variable is thus a mechanism for abstraction, for making apparently dissimilar computations manifest an underlying identity. For making apparently dissimilar computations manifest an underlying identity. Like, I really don't want to go too deep with words, but this is a kind of a very nice way how to, you know, describe, as he says, apparently dissimilar computations, as to have a certain kind of same identity. And identity is interesting to use that word because, right, in Nix, like, wait, I'm in Nix now, exit 0. So if I go to Nix REPL, right? So if I go to Nix REPL, identity, let's call it id. Okay, identity is what? Is, how do you do it in Nix? So it's X and then X, right? Identity XX. So identity 2 is 2, right? So I give it a 2 and it outputs 2. So this is identity is a kind of a function that as an argument takes whatever you give it and it outputs whatever you gave it. So it has no type. I mean, that's the type. I think the type would be like all type. No, all type is not the right word. But in some sense, it has a type, the most global type you could have. How do you inspect types in XREPL? But this is basically like no type, right? Because it takes whatever, identity, you know, 0. It's just like whatever you give me, I give back. That's the identity. And it's interesting that some variables are called identifiers, which is kind of like, what's the difference between an identifier and a variable? That's also interesting. I think my CPU is going well. I've increased the buffer size. I've increased the buffer size for 2,500 to 6,000, and it's slightly better actually. The CPU is not jumping so much. So the difference between an identifier and a variable lies in their roles and how they're used in programming. Identifier is the name given to elements in a program, such as variables, functions, constants, or classes. Purpose, it is label or reference used to identify a program element. Well, you could say that's a variable also. Age is an identifier for the variable storing the value 25. Age is an identifier for the variable storing the value 25. Oh, it's kind of just referencing. So it looks like age is like a name, and the variable is like something between the name and the location. Yeah, I'll also watch the value of values, a famous talk by what's his name, Rich Hickey. It's a really, actually it's a nice talk. I didn't really think much. I haven't watched any of his talks for like a couple of years, and that speech was really nice, where he talks about the places, right? Because like, what do you think about, like, what's value for you? Is it a place? It's not a place, right? It's a value. The place can change, but the value remains, you know? It's just, it's a very nice talk. It's a very nice talk. And there is also like a transcript if you don't want to, maybe I will just actually expressions, references. Yeah, I'll just write here actually. References. John Whittington, installing OCaml. So this is the installation part actually. I'll just copy this. Installing. I'll do this, and then we're doing John Whittington, the only video you'll need is the knee of him, let definitions. How do I share? Am I sharing just the video or subscribed? Wait, I'll just open this and I'll share the playlist. Michael Clarkson. Yeah, my CPU is better now. My buffer, yeah, definitely if you have a problem with OBS, the Curry Howard correspondence, this is nice. He also has camels, look at this. This would be a nice thing to watch. Proofs about lists, nice. So if you go to playlists, OCaml programming correct, view playlist, 203 videos, they are short. Shuffled, where do you share? No, bite size. Play, here, this button. Copy, right, editing. I'll just share it here. So this is the Cornell course. Cornell OCaml course. Right. And maybe I'll also put the value of values because it's just nice. The value of values. The value of values with Rich Hickey. Yeah. It's you know, it's good. It's good. Check it out. It's good. I'll put that too. The value of values, talk by Rich Hickey. There is a transcript. So I guess if you, the value of values, MD or something, I found the value of values, Rich Hickey. Talk transcripts, yeah, this. Actually, if you don't have time, really. JaxCon, this was 2012. This is a nice one. And you have the slides here also. Yeah, I kind of like this. All right, editing, slides and transcript. Yeah, I'm not, how do you put like double? Do I just write it like double? Will this work? No, it will not work. Maybe like this. No, it will not work. Actually, let's do it like this with a star. No, that's not right. Then it's not, then it's just, I think it's just a star and you kind of go inside. Yeah, slides and transcript, right. Okay. "20 minutes. So, yeah, this is about names. Let's check names, what he says about names. It's interesting. So he said, yeah, I was reading, look at me, I totally forgot. So, yeah, actually, it's just cool. I have to put this also. Editing, okay. So this is called abstraction. What's the name of this book? Programming Well. Programming Well. Programming Well. So this is CS 51. Programming Well. Right. Okay. Anyway, it's just interesting for each of several values. Again, the details. This mechanism, the state variable, is the same mechanism for abstraction. For making apparently dissimilar computations manifest an underlying identity. This kind of. It's just interesting. So this particular style of programming, imperative programming, is undoubtedly most familiar to you. But there are many other abstraction mechanisms than state variables and loops underpinning many other programming paradigms than imperative programming and allowing many other ways of designing computations. It is the goal of this book to introduce several such abstraction mechanisms, provide practice in their use and application, and thereby open a broad range of programming possibilities not otherwise available. So I guess maybe you could say, like in functional programming, the variable itself, it's not about what kind of a type is it, but the function itself. So an important abstraction mechanism. So is the state variable basically the abstraction mechanism in the imperative programming? So we will begin, he says, with functions and functional programming ideas. And then he goes to also an extended example. So this is what happened here where I got stuck a bit. John Whittington does also the GCD. And in Programming Well, which is kind of nice because they compare two ways how you do GCD, an imperative way and functional. So by way of, so I want to go through this again. By way of example of the distinction between imperative and functional programming, consider the very practical question of tiling a bathroom floor of size 28 by 20. Oh, this will be a little bit more complex algorithm for the GCD. We can tile such floor tiles with that of 2, 2. So you can tile them by 2 by 2 since both 28 and 20 are evenly divisible by 2. Yeah, but how do you know that they are divisible by 2? But 3 by 3 tiles don't work since neither 28 nor 20 are divisible by 3. If we want to use the fewest tiles, it would be useful to know the largest number that divides both dimensions evenly. Their greatest common divisor. GCD. Here is how we might program a calculation of GCD in an imperative style. So now he's writing like 2 styles, which is kind of cool. He's doing a style, you see this? So let GCD down AB. Yeah, maybe I could do this. Let GCD down AB. Let guess. Can I do this in UTOP? I think I could do this in UTOP actually. Let's exit this. How do you just exit this? Oh, I forgot how you exit. How would you exit? Exit. Control D, all right. UTOP. So let GCD down AB. But why let GCD down AB? Let GCD down AB. Why is he naming it down? Let GCD down. Oh, GCD down. He's just calling it GCD down. That's like the most inefficient way how you find it. Because I was practicing this by hand yesterday. Because there's just no other way. You just have to practice it by hand. It is one thing to understand it like this, and that's great. But then you still have to do it by hand. Let GCD down. Okay, let GCD down AB. Right. And that's what? Maybe I could do this. How do I do this in a ls? Let's make a directory code. Let's go into code, make dir ml. Let's go to ml. No, let's not ml. Wait a second. cd code, remove ml. Make dir OCaml. Right, cd OCaml. And could I do neovim GCD down? GCD down? Or with snake case? GCD down ML. I think like this, right? It's downloading? Oh, nice. So I've installed Vim Kickstarter, which is not a NeoVim distribution, just a basic, just a start. So it just has the most basic plugins actually needed. Has been installed. Okay. So how would we do this? Oh, it already actually let GCD down. Why did it go? It's funny. Let's try again. Let GCD down A and B, right? So we have an A and a B. So this will be the greatest common GCD of 12 and 18, I guess. So let GCD down AB. And now, we are defining a function actually. We are using a let here to define a function called GCD down that will have 2 parameters, A and B. We will provide the arguments, which will be 12 and 18. Let's say 12 and 18. And, oh, the tab is like 1, 2, 3, 4, 5, 6, 7, 8 stops. Maybe 4 would be better. Yeah, okay. So let guess. So then it starts with a guess. So one of the mental things you have, like, okay, you might even know how the algorithm is going to work. Like when I like kind of show this to my wife, not the code, I showed it by hand, and she understands it. But if I would show her the code, she wouldn't understand it. I mean, I wouldn't understand it. Even though I know what's being done, it's interesting. It's totally, and it would be nice in schools if they would actually teach kids to just write code, you know, instead of doing stuff just by hand. Oh, I have some dust here. Okay, let's guess. So it first starts with a guess, and then ref min. So he says this procedure works by counting down from the smaller of the two numbers. And it's interesting. She said, like, what's guess? And I was like lost. Like, what's guess? Like, why is the guess 12? How does it know that it's 12? Well, we write it. And what's ref? Why did he write ref? Maybe because like a reference. This procedure works by counting down from the smaller of the two numbers, one by one, until a common divisor is found. Since the search for the common divisor is from the largest to the smallest possibility, the greatest common divisor is found. Yeah, well, I would like a more detailed explanation, actually. Sorry. I mean, this all makes sense, but it just, well, that's why we have ChatGPT, right? Give me a more elaborate explanation. So let's break this down step by step. So the function GCD down computes the GCD of the two integers a and b. So starting with the small of the two numbers. So you got to start with the small of the two. So that's what we say, right? A lot of the things, wait a second, regenerate, come on. So we somehow start with this, but it's just different way when you write it, I guess. Let GCD down AB, let guess. So you have to name it, right? We kind of presume a lot of steps when we think and do by hand because, you know, we don't have time. So let's break down. So start with the smaller of the two numbers because the GCD cannot exceed the smaller number. That makes sense. But what does that tell you? What do you mean start with the, I mean, I guess the sentence itself, start with a smaller number, presumes that you know already the end. What are you going to do? It's funny. It's like you cannot start from something. You know what I mean? It's like starting from the smallest number. It means I know how am I going to define the body of my function. And I will define it such and so. And in order to get it, I have to start with a smaller number. So it starts already with a smaller number. So someone who does not know this, and you read this and let guess. So let guess. So this is guess. This is, I guess this is different, I guess. This is a function definition and this is a let definition. So this actually, it was said in this video, there is a difference, right? So we are naming, where is it? Where is it now? That's this, programming well. So let guess, can I put like dark mode here too? No, it won't work. It's a PDF. So let's check this out. Yeah, like these two things look the same, but they're not. So let GCD down AB is a function definition. We use let for a function definition. And let guess is a variable. And in this case, the guess will be a mutable variable. It's in imperative style because guess will be changing. Look at this. We are changing guess. We are changing it here also. and then we are comparing it with A and B, right? And finding the minimal of A and B. But just what's this ref? I understand ref, so why do we need ref? Let guess. Does this make sense? I'm kind of jumping back and forth, but I think I'm onto this. I'm onto you, OCaml. So start with the small of the two numbers. Okay, the ChatGPT is saying, babe, okay, this is the general approach. Right. This is a good way to start. So you start with a general approach and then you do the code breakdown. I guess maybe the mistake what I'm doing sometimes, I immediately start with a code breakdown before somehow defining a general approach. Defining a general approach is kind of very functional. So the following approach is start with the small of the two numbers. Gradually count down from this starting point to find the largest number that divides both numbers evenly. So the meaning of evenly, it means that there are no remainders left. The first number found that divides both A and B evenly is the GCD. So here's the code again. Start with the smaller number. Why is it ref here? I guess, okay. Ref, okay, he's saying that here, okay. So start with a smaller number, right? While A mod guess, this is also confusing at first because we have an or here. So while, and we have a while. I didn't know that OCaml has whiles. So it's almost like while this or this is what? True. Okay, while this or this is true, but not both, I guess, because if both is true, you would have to stop and return the final guess, right? So it's interesting how this is like while this or this is true, maybe this is not, this is exclusive or not, I'm not sure. While this or this is true, do this. So decrement the guess by 1. Then when you decrement it by 1, how does it go back? Decrement the guess by 1, done. And then start with the smaller number. And then the let guess is, yeah, this is just, I think the part which may be confusing is how does the computation restart? Restart in the sense that you define something, and how does it go back and start the whole thing again? So now let's go through each part of this code. Initialization. Funny word. So we have a let guess. So we have a let guess equals ref min AB. So the minimum, okay, I think minimum is already defined in the base as a function that just finds a minimum of 2 numbers. I think it won't work on 3, yeah. Minimum of 2 numbers. So if you give it 2 and 3, minimum would find, I think we can even try it out. Wait a sec, I can just open utab here. Let's see this. Min 1, 2. Right, it found 1. Min this and this. You see it finds the minimum. I think there is also max 1 and 2. And I think you can combine it like min of 1 and max of 2 and 3, right? I think I don't have to put actually these brackets here. So the minimum of 1, let's do 4. So the minimum of 4 and the maximum of 2 and 3. So we have the maximum is 3 and the minimum of 4 and 3 is 3. So we should get 3. Okay, so that works. So let guess is, but now this ref kind of a thing. So let guess is ref. So min AB finds the smaller of the 2 numbers A and B. So the reason is simple. The GCD cannot be larger than the smaller number. Example, if A is less than 12 and B is less than 18, Minimum of 12 and 18 returns 12. But it's just, you could say why let guess isn't just min 12, 18, right? Like we could do let guess equals min AB, right? Unbound value A. Oh, we didn't declare it. Maybe we could do like incrementally build it here in Utah. So let my fun AB equals let guess equals, and we just put it in guess. I don't know if it will work. Min AB. Oh no, let my fun AB, and well, you could do let my fun AB in min AB. Min AB. No, I would have to define it in let. Let A equals, yeah. Let A equals 5. Yeah, I'm not sure how to do this. Well, let my min. Let's try let my min. Let my min AB equals min AB. Right? Will this work? So my min, I've basically just renamed it. My min 12, 18. Yeah, this is really silly. I've just renamed it. And so that it calls min. But what do I want to do? I want to, yeah, I'm not sure what I want to do. Let's check again. Let guess is ref min AB in. I guess this ref is kind of confusing. In. Min AB finds the smaller of the two numbers A and B. The reason is simple. The GCD cannot be larger than the smaller number. So if A is 12, B is 18, min 12, 18 returns 12. So makes guess a mutable reference, allowing us to change its value during the program execution. Yeah. This is confusing. Is ref a OCaml term, or are you just calling it ref? Oh, it's like in Rust with mute. It is a specific OCaml construct for working with mutable values. So what is ref in OCaml? A built-in OCaml function that creates a mutable reference to a value. This is a dereferencing operator, an assignment operator used to update the value stored in a reference. Oh, I see. So did he use that actually? Oh, he did it. Look at this. We don't know this. So he updated it. Look at this. He updates it. So you have a ref and a this. Yeah. I guess this is too soon to do this. That's not in this book that we're doing. Maybe that's why here the GCD that he showed us, it's not. Let's check the GCD what John showed. Euclid's algorithm is simple to write as a function with two arguments. Let rec GCD AB. If B is 0, then A. Else GCD B, A mod B. Wow, that's really short. That's very short. Isn't that a bit too short? Yeah, I just need more time with these things. Wow, this looks this implementation uses recursion and is based on Euclid's algorithm, a classic and efficient method for finding the GCD of two numbers. Wow. Yeah, so there are actually a couple of things that maybe they don't expect us to just really understand every word what it means. It just explains it generally how the code works. Yeah, I understand this. So one of the things that's important also to read a lot of code, even if you might not understand everything, you kind of read it and it kind of mentally helps. And then he's doing the same countdown algorithm, which is interesting. How do we write a countdown in OCaml? A simple countdown. I did this in C actually, the countdown, and I used a while loop and a for loop. Wait. Wait, I'm a bit lost now. Maybe let's watch this. I'll just watch this a bit.
That response again. Again, let's start by reading it right to left. Let x equals 42. What did that result in? It resulted in a value 42 whose type was int, and it is bound to the name x. That's what the val x there means. So now if I read it left to right, I've got a value named x, which has type int, and is equal to 42. And when I evaluate x itself at the next prompt, what do I get back? I've got 42, and it's just an int. 42 itself is the value of that variable x. X is the name, 42 is the value.
Okay. What kind of let's see what he did here. Maybe let's do this. Let's look at all the examples he did. So okay, he defined, okay, we have a number, right? We have a value. Then we name the value with the let statement. We name it, we give it a name. So right, let's say we have a number 1, 2, 3. We give it a name. Let x equals 1, 2, 3. X is right. That's what he said now in this lecture. You read from right to left. 120. So 1, 2, 3 has a type of an int. Okay. To write all this in a single expression, we can use the let in construct. Okay, he's introducing here the let in. To write what? Let x times x. Okay, so he's saying like if we write x times x times x, now we can use the x, right? And we can do some calculations. But we can also do this in the same expression, such as let x equals 2 in x times x. So now we have int 4. I guess you would call this an anonymous function, or like a lambda function in some sense, because you cannot call it again. I mean, you would have to retype it. You have to define all this again. You cannot call it again. So in that sense, I think this is an anonymous function defined by let. OCaml, right? Let a 500 in. Now this is a nice teaching tool. He does. It's not a recursion, but in some sense, he uses a name that is in the outer scope and he calls it in the inner scope. So let's say let a equals 2 in, and then let b equals a plus b. Yeah, you could do it like that. No, but we have to see and no. Okay, let A equals 2 in what? Let B equals, this could be called partial application, not sure. Let B is A times, well, maybe you could say let B is A in what? A plus B. Yeah, he could have did, it's nice what he's doing here. Like I could do like let B equals 3. Right. Like this. Int 5. So let A is 2 in, let B is 3 in A plus B. So we are calling the A from the outer scope. And since B is inside of A, so in some sense A is here like a global variable. So B can call A. B can call A from outside. But it's nice that he recalled A here. So he defined B in terms of A, which is very nice way, I guess, to introduce slowly the recursion calls, because you're calling this time a name inside, like you're using the name inside again to define a name. So like let A equals 2 in let B equals A, I don't know, A plus A, right? In A plus B. So in some sense, when you first see this, you might get confused. So now it's 6. So where A is 2 and in what? In let B is A plus. So B is defined in terms of A. In terms of A. Yeah, you could just have it. Well, maybe a more simple example. Let A is 2 and let B is A in A plus B. Right. You could say why, because let A is 2 in let B is A in A plus B. We're just basically we're just adding A, as in let A is 2 in A plus A. So this is the same as saying let A is 2 in A plus A, which is 4. But let's say, yeah, this is just redefining B as A and then saying A plus B. So this thing is the same as this thing, but it's just interesting. I think this is kind of nice, a nice way to introduce recursion of sorts. I guess maybe I should copy this actually. Editing, learning OCaml, right type. Interesting way to introduce OCaml. Maybe like interesting way to introduce recursion. Interesting way to introduce recursion. Well, it's not really. Well, it's not really, but we are kind of defining the B in terms of the value of A, right? Or just in terms of A. So the outer scope value is called in the inner scope OCaml, and we have this, right? And this is the same, right? Which is the same as this. Yeah, this is just interesting to watch. Okay. Let's close this. So yeah, so we can also make a function whose value depends upon some input. So now he introduces the notion of a function. So the value of the function depends upon some input. That's nice because yes, the value it's something nice what I've asked a kind of famous Hascaller, like what's a function, and they said really, they gave me a really long answer on Twitter, but interesting what they said is function is not data, it's co-data, because you can actually not destruct it. You cannot deconstruct it like data, right? Let's say you have a data structure like a list and you can deconstruct it, but you cannot do that with a function. Yeah, sure, you can see how it's built up in terms of how the function works, but you cannot actually deconstruct it until you run it. Only when you run it and you see what's the output, you can kind of see, you can see what's a function. So it's kind of a weird kind of a beast, you know, like you have to, it's very interesting. I've never thought of it like that, because you have to run the function so that you can see what it does. And it's defined by its inputs. It's not defined by itself, right? Like some kind of a data structure. So there is, of course, you could say that a table, I've heard that, you know, many times, like a table, like a spreadsheet of sort, it's a function from A to B, right? Like A times B gives you something. Like this point times that point gives you a third point in the 2D map. But it's interesting, yeah. So then he's defining a cube x times x times x, cube 200, right? We chose cube for the name of the function, x for the name of its argument. OCaml replied by telling us that its type is int. This means it is a function which takes an integer as its argument, and when given that argument evaluates to an integer. To use the function, we just write its name followed by a suitable argument. In our example, we calculated 200. Okay, this kind of makes sense again. So let cube false. Cube false. This expression has type bool, but an expression with expected of type int. Yeah. And then he made a negative. Okay, now he's introducing bools. Yeah, it's like we could do let square x equals x times x, right? So square 2, it's 4. But this is working with values. Now he's making a function which checks for a boolean. Okay, I think the point was because so far the functions were, if we go, you see this is a function, like how do I have like show square? No, show square. Yes. So if you write show square, it would show us the type of a function. So square is a function from an int to an int. So far, the functions were from the same type to the same type. But now he's showing us the function that let negative x, if x is less than 0, then true, else false. So let negative x is, if x is less than 0, then true. Then true what? Then it's true. But we're stating that x is negative, so it's true. If x is 0, then true. Else false. So right, now we have a function, but that goes from int to n bool. So now it goes from one type to another. So if we do negative -2, can we do this without the parentheses? No, we have to do negative -2 bool true. So maybe we can do also show neg, right? it's a function from int to a bool, and if we do show, can we also give it an argument -2? Syntax error. No, we cannot. But otherwise we can. Interesting. Okay, we cannot do that. We can just inspect the type of a function, not a function applied to an argument. Let -x is x less than 0. Oh, this is nice. Now he's showing two ways. Yeah, he's actually, I like this book because he really tries to go step by step, which is, it's nice. It's kind of smooth. You really want the book to go smooth. Like, okay, this is maybe not so smooth, you know, maybe they expect us to know a lot more, right? So the code is explained here, but yeah, well, okay. So let -x is, so now we have two ways. Now he's introducing two ways to define the same thing. So what's the difference? So let's call it actually let's call it neg a x or n equals, if n less than 0 then true, neg a. Can we do prime? Can we have like prime? Let neg a prime a is if a less than, what did he use actually? X. He used the x. I remember when I was learning Haskell, they use n for the number and x for a char. I kind of like that. Let neg. So it's n for a number, and s for a list of numbers, x for a char, xs for a list of chars or a string. Let neg n is if n is less than 0, then true, else false. So neg prime -1 bool true. And now let's define neg prime. N is if n is greater than 0. But what is he doing? No, he's not using an if statement. Let neg n is equal to, well, he's stating what neg x means. Yeah, this is kind of different. So negative n, what does that mean? It means that the n is less than 0. Right? So it's kind of, I think it's kind of less computation. In the first neg, if this is true, then else, otherwise say false. But here we don't have a guard. I think this is called a guard, because guard will make some kind of transformation. So if this is true, then true, else false. So if this is true, then true, else false. Let neg prime n is less than 0. And we have the same type. And let neg prime -1, syntax error. Oh, neg prime -1, bool true. So we have two different ways. I think this has to do maybe with pattern matching, which would be kind of interesting. So in how many ways you can define certain things. This is a nice side of functional programming. So because x less than 0 will evaluate to the appropriate Boolean value on its own, true if x less than 0 and false otherwise. Here is another function. This time of type char bool. Okay, Now he's making a char ball. First we had an int ball, now a char ball. It's nice. It determines if a given character is a vowel or not. Very simple. This is actually very beginner stuff, and I kind of like it because I feel like a total beginner. I always feel like a beginner. I think the important thing is to finish a book. I started way too many books. Yeah. Let is vowel C. Okay, so this is a function from char to bool. That's what we did last time, is vowel C. So C, he wants to write like a character, is vowel C. I guess what may be confusing for someone, like this doesn't have to be C, it's not about C. Maybe that's why it's kind of confusing, like is C equal to A? Maybe that's why X might be, mentally. Look at this, and then he's checking it here. Is vowel X? No, this is wrong. Is. And now we're gonna check. So this is an OR. This thing is an OR. I can actually pause. Oh, no, I can't. Okay. How long am I recording? 1 hour and 7 minutes. Well, I still am doing what I did last time. Yeah. Let GCD down. Yeah, I guess it's like this, you just have to, do it. And, practice. Well, at least I understand a little bit more than last time, and I'm happy with it. And it's important to reread also. It would be too much, to just read through and just do, add to 10. I would like to implement next time a countdown of sort. I think I'm going to just keep on reading today a bit. Maybe rest, I will not record. I'll just read a bit and process things in my head. Maybe a little bit more, and set up my NeoVim. I want to change the theme. Okay, so that's OCaml number 2, right? So I hope there will be lots of more. All right, bye-bye.